Hi, uh, myself Shankha Subra Sanyal, and I'll be taking you through this journey of time and motion. Well, first of all, let us see what we are going to learn in this chapter, what we are going to understand in this chapter. This is a very interesting chapter. We'll try to explain the concept of speed over here, the measurement of time. We'll also try to know how to measure speed. And yes, last but not the least, we'll try to know how distance time graphs can be described to represent the motion of object in pictorial form. You know what? Our daily activities like walking, running, closing the door, etc., all involve motion. There is a change of position of the object involved in these activities. In fact, the flow of air in and out of our lungs is also an example of motion. You must be seeing these totos plying on the road that carry passengers from place of pickup to the destination. They too possesses motion. Although in this case the position of passengers is changed from one place to another. So what is motion? The motion of an object is defined as the movement of that object from one place to another. An object is said to be in motion or moving when its position is changed with respect to time. Remember, we just mentioned two very important things over here. One, we mentioned about the movement of a body, and yes, the second important thing was the time. So what are motions? The motion of a car, maybe the movement of the fan, the hands of a clock, they all classify as motion. So how can we define motion is a $1,000,000 question over here. It is the change of position of an object with respect to time. A book falling off a table. Yes, it's also an example of motion because the book was on the table, it fell down, so it's motion. Water flowing from a tap, right? That too qualifies as a motion. Rattling of windows, rattling, the sound that the windows make, that's known as rattling. rattling. I believe you people are aware of this word. They all exhibit motion. In fact, you won't believe even the air that we breathe exhibits motion. Interesting, right? Everything in the universe moves. In fact, we live in a universe that is in continuous motion. The fundamental particle of matter, that is atom, is also in a constant motion. Atom, you have heard about it? ATOM. Anything in this universe is made up of an atom. It's a very small, very tiny particle. It was first coined by Democritus. He was a Greek philosopher. But before that, there was an Indian rishi. His name was Rishi Kannad. He called atom as Param Anu. What is it? Param Anu, which means the ultimate particle. To know more details about this, you have to be in class 8. Class 8, class 9 chemistry, you'll be learning in more details about atom. So let's come back to the topic. Every physical process in the universe is composed of motion of some sort or the other. The motion can either be swift or slow, but motion exists. It is important that we give due attention to study of motion because of its importance in the physical world. Basically, there are 4 types of motion. First, rectilinear motion, circular motion, rotational motion, and periodic motion? Well, the simplest of these all is rectilinear motion, also known as linear motion. Let's see what is rectilinear motion. Motion in a straight line, or when objects move in a straight line path, is known as rectilinear motion. What could be examples of this? The motion of the school bus on a straight road. The march past of students on sports day. Isn't it? You people must have enjoyed the 4 teams of your school doing the march past around the school ground on sports day. Yes, that is rectilinear motion, because they all are moving in a straight line. And yes, naughty boys, when you leave the assembly ground after the assembly, what do? You all move in a straight line, right? These all qualifies as rectilinear motion. Then what is circular motion? A round path having the shape of a circle. You know a circle? Yeah, a circle is called circular path. So when an object moves in a circular path, its motion is said to be circular motion. An example of this could be the Earth's movement around the sun. You must have seen the sun moving, the Earth moving around the sun. In fact, all the planets move around the sun. You people must have sat on a merry-go-round. Over there you must have seen that you are going round and round and round, right? That's circular motion. Have you all rode a bicycle? The paddles of the bicycle also qualifies as a circular motion. The third one is rotational motion. Now what's the third one? When an object turns or spins on its own axis. How many of you have ever spinned a top? Lattu. Have you turned it around? Lattu? Yes. So that's what rotational motion is. The turning of the blades of a fan is also qualified as a rotational motion. The turning of the hands of the clock, yes, it also qualifies as rotational motion. In fact, the Earth's movement on its axis is known as rotational motion as well. The fourth one, periodic motion. The motion which repeats itself after regular intervals. Like if it is repeated after every interval, it is known as periodic motion. It is also known as oscillatory motion. So please mark this word, oscillatory, O-A-C-I-L-L-A-T-O-R-Y. Oscillatory motion. Where do you actually see this oscillatory motion? Have you ever been to a park where you have seen a swing? Yeah, jhula. In the jhula, you must have seen that when you are moving, it goes back and forth, right? That's what we call as periodic motion. You must have seen a pendulum, right? The pendulum goes ting tong, ting tong, ting tong. That's the motion of the pendulum which qualifies as periodic motion. Have you ever heard the school bell ringing? Yeah, I enjoy this the most. When I was in your class, I used to enjoy that the most, because the class is over and we all can go for our break. We can go for games. Yes. So when this hammer is hitting the electric bell, the motion is again a periodic motion, because it hits again and again. The motion of an athlete around a racing track, who is taking a 1500 meter round the track, they all qualify as periodic motion. Did you get this? Okay. So before we go any further, let's play a small game, right? You're with me? Sure? Okay, I'll give you motions from day-to-day life. And what you need to do, you need to classify them into 4 types of motions that we have just discussed, right? Are you ready? Game for it? Okay, let's begin. Motion of your hands while running. Yes, when we are running, we are actually moving our hands like this. Tell me, what kind of a motion is this? Yes, right. That's oscillatory motion. Now, have you seen a horse pulling a cart on a straight road? Yes. You think yourself to be a Maharaja, right? Sitting on the horse cart and the horse is pulling you on the straight road. What kind of a motion is that? Yes, you got it right. Yes, thumbs up for that, rectilinear motion. Right. All ready for the third question? Yes, it is. And it's on your screen right now. Motion of a child in a merry-go-round. What kind of a motion is that? Well, that's circular motion, because you are going, I just discussed, right? You are going round and round and round. So that's circular motion. Let's go for the fourth one. Have you seen a seesaw? You must have seen, right? It's there in the lawn. So, if you sit on a seesaw, what kind of a motion you would be in? Yes, right. You got it. Yes, it is oscillatory motion. Now, a few minutes back, I just had a talk regarding the hammer bell, right? Hanging, it going down and hammering against that gong. So what kind of a motion is that? Right? Oscillatory motion, you got it right. Okay, guys. Those who come from Siliguri to school, which bridge do you cross by? Which one? Okay, Mahananda Bridge. Great. So, what is the motion of a bus crossing Mahananda Bridge? What is it? Yes, you got it right. और आपको मिलता है 1 करोड़ रुपए. Yes, it is rectilinear motion. Excellent, guys. So this brings us to the end of our topic today. Thank you.